Chemistry with Coach Jakes.
What's going on, people? Welcome to Chemistry with Coach Jakes, where we make chemistry easy. I am Coach Jakes, your new favorite chemistry teacher. In this video, we're going to talk about the ideal gas law. So at this point, we've already talked about Boyle's, Charles, Gay-Lussac. Great, cool. But there was one area where all of those fell short. They talked about pressure. They made sure they included volume. They included temperature. They didn't combine them, and they didn't talk about the quantity or the amount of gas particles in the solution. They didn't talk about the total number of gas particles that make up a gas. And so in the ideal gas law, not only do we talk about pressure, volume, and temperature, but we talk about your favorite word for quantity, the mole. That's right, the mole. In this gas law, we examine how the quantity of a gas impacts the pressure, the volume, and the temperature. In other words, if there are a lot of gas particles or fewer gas particles, how does that affect the pressure, the volume, or the temperature? We can also use this law to help us determine the number of moles in a sample of gas based on its pressure, volume, and temperature. All right. So now we're going to go to our PhET simulation where it shows us the gas particles in the box, and we're going to examine how adding or taking away particles in a gas impacts the pressure, volume, temperature, and get a big picture of that entire relationship. Check it out. So in the ideal gas law, in this one, we can't actually count the moles, but we can see what happens when we increase or decrease if nothing is held constant. So volume, temperature, and pressure are all free to change. Now, these right here are the particles. These are what we're looking at when we're talking about the moles, okay? And the more particles we put in here, the larger the number of moles. And we'll see that when there are more moles, obviously the pressure increases, okay? Now, as we change these things, right, let's say we increase the volume, all right, number of moles stays the same, pressure decreases, the pressure decreases. We can cool it down. You'll see the temperature drop. You see the pressure decreases. The quantity stays the same because we haven't added or taken away. All right, if we add more moles of gas, we'll see pressure increases again. Temperature in this case stays the same. If we decrease, pressure changes. We can increase the temperature. So obviously you can see that. So here you can see that the number of moles has a great impact on pressure, volume, and temperature of a gas. So again, in the ideal gas law, we are simply taking Charles, Boyle's, and Gay-Lussac's laws. We're adding them together and also incorporating the quantity of gas particles, which we call moles. All right. It's a very simple, easy formula. And the math is also simple. Check out the next video solving ideal gas law problems. Get some practice problem help. I go through it step by step so you can understand what's going on when your teacher says, hey, solve this problem. This has been Chemistry with Coach Jakes. Hope it helped you in some way. If you did, like it, subscribe to our channel, go follow us on IG at Chemistry with Coach Jakes. Tell your friends, your classmates, your frenemies, and your enemies. Let everybody know that if you need some help with chemistry, this is the place to go. Chemistry with Coach Jakes. Take care. Stay safe. Be blessed. Peace.